Alright, so this is called null factor law exercise 5F. You are now solving quadratic equations. Later on I'll show you on Desmos what you're actually truly doing. But at the moment I'm just going to get you to understand a very simple idea. It's called null factor law. Null meaning zero or nothing. And a factor usually is, if you're multiplying two things together, they're factors of each other. So 3 times 4, 3 is a factor of 12, and 4 is also a factor of 12, because 3 times 4 gives you 12, right? So what we're saying here is, when you have something times something equals 0, so A times B equals 0, then null factor law says that means A could equal to 0, or B could equal to 0. Now, often this logic, a lot of students kind of glance over that when they, especially year 10 mainstream, they usually glance over that very simple fact. But it's actually a very powerful, simple idea. And the way I try to explain it to my year 10s and even juniors is I say, on a logical sense, you guys didn't need to know null factor law. You probably knew it intuitively. It's just that we're spelling it out algebraically. This is what you would have done in primary school. We would have said, something times 3 equals 0. What's that number? And most of you would say? 0. So you know that this number had to be 0 in order for that statement to be true. So 3 times something, if the result is going to be 0, we know that one of them has to be 0. Then I say, all right, well then let's swap it around. What if I did 3 times magic box, and we know the result is 0. Does it matter if I swap the order? What's in the box there? No, it doesn't. Still 0. Yes, same magic box.
So it's basically X for the box.
Very good. That's the difference that primary school students don't see versus high school, where we use magic box as algebra. We use letters, pronumerals, to represent a number. Then we do the same thing here. When I then ask, generally my 8s, I ask them, what is magic square times magic triangle equals 0? And I ask them, what can they tell me? And then most of them can tell me exactly what I just said before, but logically, what do you think they would have said to me when I asked them? Yeah, so some of them will say 0 times 0 equals 0. Then I would have to say what? Why can't these two be zeros? Yeah, they're not the same shapes. Usually when you write different shapes, it implies that they're different numbers, right? So yes, 0 times 0 is possible to make that statement true, but because you're using a square and a triangle, you're implying that both numbers are not the same. Okay, so technically, it could have been maybe magic square is 0, or it could have been the other way, magic triangle is 0. And that's what the year 8s eventually come to the conclusion. They're like, well, one of them has to be 0. That's the same thing as what I'm writing here. A times B equals 0 at a year 9, year 10 level. We just don't use magic squares and magic triangles, but it means exactly the same thing. A represents a number that you don't know. B represents a number that you don't know, but if you multiply them and equal 0, one of them, on a logical sense, has to be 0. Now, that doesn't even apply just to two numbers. And that's the thing that with year 10 mainstream, I find they're limited to exactly what we give them. And I asked them, what if we had A times B times C times DE equals 0? And if I asked them that logic, we had to break it apart, we can still say the same things again. In this scenario, if you're multiplying them all together and it equals 0, one of the facts that we can say is one of those has to be 0. We just don't know which one. It could be this, it could be this, it could be this, or it could be this. And then we take that logic, and if I apply it even a bit bigger, instead of the letter A, what if I changed it to x minus 1 times, and this is funny, I do this with my U10s. And then they get confused. All I did was I just added an extra number. So I added multiple letters, they're okay. But then as soon as I put a minus 1 there, something like, in the brackets, it's like, oh, no idea. But it's the same concept. I'm still saying the same thing. I'm still saying something multiplied to something, it's going to give you 0. So based on the logic, you would say, well, if two things are multiplying to each other, is equal to 0, one of them has to be 0. But here's the fact. If one of them could be 0, that means this entire thing, x minus 1, could equal to 0. I'm not saying it is. I'm just saying it could equal to 0. Or maybe this one over here, magic triangle, could equal to 0. Now, out of the two, so you've got two possibilities here. X could be 0 to make that statement true. But over here, what would x have to be in order for it to equal 0? What would x have to be? Not negative 1. 1. 1 take away 1 is 0, right? So, logically, at this point, you're just solving for a linear equation where you're saying add 1 on both sides. This is what quadratics is. That's what we're actually doing. We're just trying to solve for something times something. Why did you have to learn to factorize? Because when you factorize, you end up with two brackets. Those two brackets mean something times something. That's why we wanted the factorization. And this is why if you can't factorize, you're already locking yourself out on solving. So solving cannot happen until you learn how to factorize. That's why learning D and E was important. And you had to do it at a very fast pace, and it had to be accurate as well. Because if you're doing it wrong, then the whole thing's wrong. Okay, it's like your times tables. If you multiply wrong, then all your fractions are wrong. Yeah? So today's lesson, we're going to look at the different ways that I can write an equation and how you then eventually start to solve or factorize first before you solve. Because the goal is to get something times something. That's what we want. All right? Let's look at the first example. Here we go. Let's solve for this one. I gave you a monic one to start off with because it's a bit easier instead of a non-monic. So, monic. Let's see how your last week's exercise is. Someone factorize this for me. Hands up. Yes, Una? What do you think the answer? Oh, the brackets would be. All right, let me double check. Yes, that is correct. And so again, this is factorizing bit. So you have to learn this skill first. You have to be able to do it at that pace. Then the next bit is, okay, if it does equal to 0, so if this times this does equal to 0, then what would x have to be to make it true? Now, the same logic applies. Something times something equals 0. So that means in this bracket, whatever the number x is, how do I make that 0? If this was meant to equal to 0, what would x have to be? So I'm asking x plus 2, if it had to equal to 0, what would x have to be, Joanne? Negative 2. Now you can see that one of the problems that students get into, especially at the mainstream level, is they tend to memorize. They memorize by looking at this. They say, oh, that's a plus 2? So the answer must be the opposite of that. And they do that because if you do just monic, the exercise for monics, you get only these types of brackets, and you end up just seeing, if it's 2 there, it's negative 2. If it's 1 there, then the answer is negative 1. That's how they memorize it. Problem is that, and I can tell straight away when they actually do that, by simply changing up the brackets. If I did this, then I can tell. What's the answer for this bracket? Negative 1 over 2. What do you think the year 10s would have wrote? Negative 1 or negative 2, because they're guessing. They're not understanding the theory. They're just guessing. I have no idea what I'm doing. I'm just going to write a number because one of them is going to be correct. But if you understand the theory, all I'm asking is 2 times what plus 1 potentially could make that 0, because we said something times something equals 0. Well, one of them could be 0. So 0 times something equals 0. So if this was 0, what would x have to be? Double something and then plus 1. Wouldn't make sense to say double of 1 and then add 1 makes 0. Double of 1 makes 2, and then you add 1 that makes 3. How does that make 0? So the logic is, yes, your aim is to figure out 2x plus 1. If I need that to be equal to 0, solving for that, that gives you 2x equals negative 1, x equals negative half. That is why we need to understand what null factor law is. It literally just means 2 things multiplied, or 3 things multiplied. If it equals 0, one of them must be 0. Now, let's take your understanding a bit further. Your question might, some of you might have asked or may not have asked, but the question is why do we have a 0 to begin with? So it's great that we can factorize this graph or this equation, So quadratic equation, I said it was very important to factorize. You're like, great, I've learned how to factorize. But when does it ever equal to 0? So why do I need to know it's equal to 0? So here I'm going to show you. So the logic is this. The reason why you need to know it. I know, it's beautiful. Y equals x squared, what is it again? Plus 3x plus 2. This is what the graph looks like. That's the parabola. What you've done is that when will this equation ever equal to 0? What you're saying is, when will the y coordinate equal to 0? So on this graph here, when will you have a coordinate that has a y value of 0 that's on the x-axis? What you just solved for in that particular case is when you said, what is it, the answer again? The answer should have been, I just made up these ones. The answer should have been -2, and this one should have been x equals -1. So you can see here, if I put in -1, when y is 0, you get one of the x-intercepts. And if you put the other one, -2, 0, you get the other x-intercept. See, that's when the y is 0. So when you're asking, it's like, why is it equal to 0? It's because we know on the x-axis, the y coordinates are always 0. But before they teach you to find the x-intercept, they're giving you a whole bunch of exercise to practice that skill. But it comes in 2 steps. Step 1 is to be able to factorize. Step 2 is to understand null factor law and why we want 0. Then you sketch. Yeah, so the sketching part allows you to understand what you're doing there. Another way of thinking about it as well is you're asking, when is the equation intersecting the y equals 0 line? See, I've just typed in y equals 0. This is the horizontal line. But it didn't have to be 0. I could have changed this question for you, and this is what the year 11s will do. I could have changed the question to 3x squared plus 3x plus 2 equals to 1 instead. So if I said it was equal to 1, what am I really asking you to do? This is what I'm asking. I'm asking you to figure out, when does this parabola, x squared plus 3x plus 2, have a y coordinate of 1? There's 2 points here. Those 2 points is when the y value is 1. The problem is I don't know what x is. If you have the ability to then solve this, bring the 1 across, that becomes plus 1 minus 1. Right? So this now becomes x squared plus 3x plus 1 because I minus 1 on both sides. If you can factorize that using all the skills I will teach you, right now you can't do that one yet, unless you know completing the square or quadratic formula. If you can solve for that, then you would solve for the x values when it actually y value equals 1. Okay, so that's what you're actually saying. When you say let it equal to 0, you're asking, when is this graph intersecting our horizontal line of 0? You're asking when it say equals to 1, you're asking when will it intersect 1? If you flip over the page of my notes, you see this question over here, you flip over the page. See that? Not that one, this one. The last question, you can look at it as an equation, as a random problem I created, or you can understand it visually. That's a linear equation. If you expand the brackets, that's 4x minus 8. I'm asking, when will this straight line equation equal to, and if you expand this bracket, I'm asking, when will this straight line equation intersect a quadratic? See, if I type it on Desmos, it becomes very visual on what you're doing. You're actually doing this. If I delete all this, I'm asking, what is 3x squared plus 18x equals to 4x minus 8? Oh, sorry, I should type it separately. So 4x minus 8. See that? You get 2 equations. That's what you're asking. When you actually solve for that algebraically, this is what you're doing. You're saying, when is this graph equal to that graph? And if I look at the graphing, this is your parabola. That's what you're solving for. You're finding the 2 points when the straight line will actually have the same y coordinate as the parabola. So that's at an analytical point. So at your level at the moment, you're just working on the algebra skills. But eventually you learn to sketch. When you learn to sketch, you then learn to analyze. Yeah, so everything's a stepping stone. So what do you need to do first? D and E. You have to be able to factorize first. Then today's lesson is to start building your skills to solve, because when you play with all different types of equations, eventually you start visualizing what's actually happening. Okay, this is where I eventually want you to get to. It's a very hard level to be able to visualize what's happening. But beforehand, you need the basics. So the fundamentals is knowing how to factorize and then how to solve. That requires algebra, fraction, negative skills. Okay? All right, team, let's go back. Let's do some examples now. Let's practice your null factor and factorizing skills. Let's do this one. So I'm asking, what is this parabola? When will it equal to have a y value of 0? That's what I'm really asking. We can't solve this yet because we want 2 brackets. Let's factorize. X squared plus 3x. It only has 2 terms. What's common about these 2 terms? Can I please have... Let's go with Jaden. What's common about x squared and 3x? So take out x as a common factor. What goes in the other bracket? X plus 3. Very good. So x times the x and then x times the 3. That will give you x squared plus 3x. You got something times something. The result's meant to be 0. So based on the logic, null factor law tells me one of these 2 has to equal to 0. So you either have x could equal to 0 or x plus 3 could equal to 0. So what are my 2 possible x values? Can I please have, let's go with Sage. Beautiful. X equals 0, or if you solve this side, x is equal to negative 3. So you got 2 possible answers. And if you sketch it on Desmos, you'll see this graph will touch the x-axis at 0 and negative 3. Okay, so if you sketched it, it would actually look something like that. 0, negative 3. Okay, let's try another one. What about 3x squared equals 27? Again, there's 2 ways to solve this problem. Let's try this one. What I would do in this step, to practice factorizing, if it's solving then you don't have to, but to practice factorizing, I would encourage you to take away 27 on both sides. 27, take away 27 cancels out. Now we ask ourselves, 3x squared minus 27, how do I factorize to get 2 brackets? How do I factorize? Someone have a go at factorizing this one? There should be 2 steps. Let's go. Yes, Joanne. Good. So you take out a factor of 3 for both. So what goes inside the brackets? Very good. X squared minus 9. And then from here, this is a difference of perfect squares problem. Let's pick someone else. Rowan. How do I factorize x squared minus 9? What does that become? Beautiful. Now that we've factorized it, can you see you've got something times something times something? That's 3 things multiplying each other. One of which we already know. It's a 3. So these are the only 2 we don't know. One of these can be 0. That's what null factor law is saying. Logically, if the entire result is 0, one of them has to be 0. So, let's solve for this. What would x have to equal to as our 2 potential answers? Raph, you can settle down.
Sir, they're typing stuff on my laptop and entering it into the chat.
I'm teaching. Here we go. X minus 3. What would that have to be, Sadvi? Beautiful. Positive 3 and negative 3. And again, if you type that on Desmos, you will see 3x squared minus 27 will touch the x-axis or have the coordinates negative 3, y 0, and 3, 0. That's where it will touch the x-axis. Okay, so solve for it using linear equations. X minus 3 could equal to 0, or x plus 3 could equal to 0. Then you end up with 2 possible answers. 2 possible answers. Zoom out a bit. Okay, next one. X squared minus 11. Again, our goal is to write them in a factorized form. What is x squared minus 11 factorized? Yes, Nishi. Beautiful. X plus root 11 and x minus root 11. For those who've forgotten, you're using difference of perfect squares. That is the same thing as saying a squared, so x squared, minus, and you wrote root 11 squared. That's the same thing. So you can use a squared minus b squared. B, which is root 11, and a is x. So what is my x values equal to? In this case, x is equal to... What are my two possible answers? Let's go with Toby. We've factorized it. We've got x plus root 11 times x minus root 11. What are my two possible answers? Or? Beautiful. Okay, so again, if you solve for each equation, x plus root 11 equals 0, minus root 11 on both sides, and you get x equals negative root 11. Okay, and same thing for the other one, you get positive root 11. Very good. Next one. Monic again. But this time I didn't have double plus signs. I've got one negative and one positive. Let's go with Sahaj. X minus 3 and x minus 2. Let's double check. Because there could be a 6 and a 1 as well. You could do negative 6 plus 1. But because this is a positive 6, it has to be negative 3 and negative 2. For those who did 6 and 1, it means you didn't double check that last constant. So it should be negative 3 and negative 2. Now that we've factorized it, null factor law tells me x must equal to... What did I have? Let's go with Sam. Close. It was 2 or 3. Did you say negative 3? Oh, sorry. My bad. X equals 2 or 3. That is correct. 2 or 3. Very good. Next one. Flip over the page. What about this problem now? So this one, again, you've got a quadratic intersecting a linear equation. Looks a bit different to what you're familiar with. How do we do this? Expand the brackets and rearrange. So here we go. Expand the brackets. You get 4x plus 60. Move everything to one side because if you have 0, then you can use null factor law. So minus 4x on both sides and minus 60 on both sides. These cancel out. X squared minus 4x minus 60 is equal to 0. Okay, so maybe I will take the steps carefully so you can see what I did. I did minus 4x on both sides. And then I said minus 60 on both sides. And that's how I got x squared minus 4x minus 60 is equal to 0. And you're back to monic problems again. Who wants to have a go factorizing this? Let's go with Michelle. X squared minus 4x minus 60. What does that factorize to?
X brackets x minus 10 brackets x plus 6.
Let's see. Double checking. Yes, that is correct. Negative 10 plus 6 is negative 4. So that means x is equal to what? Can I please have... Let's go with... Who would I have chosen? Let's go with Sunny. What is x equal to?
X equals 10 or negative 6.
Beautiful. So far, so good. Let's go with the second last example, or third last example. X plus 20 over x equals x. What do? If you don't like fractions, my tip has always been the same since term 1. What do? How do you get rid of that divide x? What's the opposite of divide x? Yes, Andrea. Beautiful. Times x on both sides. X divided by x cancels out, and you end up with x plus 20 is equal to x squared. And the same idea again. Bring everything to one side so you have 0. 0 is nice because you can use null factor law. That's why we do that. So we minus x on both sides, and then we minus 20 on both sides. x take away x, 20 take away 20. That's how you get the 0. And so if you rewrite it, it becomes x squared minus x minus 20. And your job now is to learn how to factorize monics. Now, monics is much easier. Who would like to have a go? Let's go with Angelica. What is factorizing x squared minus x minus 20? What does that give me?
X equals 5 or X equals... Oh,
Yep.
no, the answer. X minus 5.
Yes, that is correct. X is minus 5 plus 4. That is correct. And therefore, x is equal to 5 like you said before, and negative 4 like you said before. Beautiful. Last question is not a monic problem, but is a non-monic problem. Here we go. Let's try this one. Your job is to factorize. Doesn't matter which method you use, cross method, Punnett square, or grouping method. Give you a moment, see if you can figure out what is the factorized form of 7x squared plus 25x minus 12. Yes, Joanne? Oh, is it? Oh, the textbook might have changed. Yeah, so maybe I need to update that one. So it might be 5G. Thank you. Who knows? Nishi?
Wait, I don't know.
Oh.
This one, is it x equals 10 or x equals 6?
Did I write it before?
Anything is 10.
10 and...
Because when you take a negative out with the bracket, and then it would become...
Wait, let's see. It's minus 4x and then minus 60. Take out the negative. Let me just... Let's go. Who's factorized this? Let's go, Andrea. Shh, shh, shh. Thanks, team. 7x minus 4 and x plus 3. Let's double check. That's negative 12. That's correct. That's 21 minus 4. No, I don't think so, because 7 times that is 21x, but then this one times that is minus 4x. So 21 minus 4 doesn't give you 25, but we're close though. We're close. Anyone else slightly different, Jaden? 7x minus 3 and x plus 4. Let's see. So that gives you 12, negative 12. That gives you... Oh, sorry. What am I talking about? Sorry, negative 12 is correct. So that's negative 3 and then 28. 28 minus 3. That is correct. That gives you the 25. And you get the negative 12. Yes, that is correct. 7x minus 3 and x plus 4. Hands up if you got that one. All right, beautiful. So that's non-monic. Now answering the key question that my year 10s tend to get wrong. What are my possible x solutions? Beautiful. The negative 4 is what most of my year 10s will get. It's the next one. See how I was doing monic the whole time? A lot of students then just memorize what the answer is. It's not 3. It's not 7. You have to understand it's 7x minus 3 needs to equal to 0. If you solve for it, it becomes x equals 3 on 7. Okay, so 3 over 7 is the correct answer. Not 3 and not 7. Okay, you actually have to use linear equations to solve. Don't memorize. All right, team. I think I'll pause there. I think that's mainly the key skills. I'll write the solutions for the next bit, or you can have a go yourself as well. But that's it for today. That's solving using null factor law, but you have to learn how to factorize first. Okay? I'm going to stop there.